Hey guys, it's Mrs. Malott again. It should be Tuesday, the 18th, last day without me, so make sure you're still in your best behavior. Make sure you're doing what Mrs. Kimmel tells you to do, and you're listening. You guys should definitely have yesterday, after the lesson, had time to work on your homework and stuff like that. So make sure you're good when you're doing that again today. There's no excuses not to have all your homework done by the end of the marking period. But today we're moving on to the next part of chapter 10. We're going to be talking about our pulse. So the pulse is a rhythmic contracting of the artery, and when you feel a pulse, what you're actually doing is you're pressing it up against a bone or some other hard part in your body. The pulse, when you feel it, is you're feeling it in the arteries. Arteries carry blood away from the heart, so the A's go together. Veins return blood to the heart. As arteries carry it away, it's high in oxygen and it's being delivered to all the tissues in the body, and then veins are taking it back to the heart where it's lower in oxygen and it needs to go back to the heart to pick up some oxygen. A normal heart rate for an adult is 60 to 100 beats per minute. If it is above that 100 beats per minute mark, we say that the person has tachycardia. And if it is below, we say bradycardia. So there are a couple places in your body that you can feel an artery. The first is the carotid. That's the one that's right here in the crease of your neck. You can go ahead and take a minute and see if you can feel it. Okay, don't press too hard though. There's apical. Now this one you don't press and feel. This is the one that you would use with a stethoscope and put over your heart to hear it. The next is the brachial pulse. That is right here, kind of at the inside of the crease of the arm. The next is the radial, which is on the thumb side, right here at the wrist. Take a minute and see if you can feel that one, and the brachial pulse. The next one that your book talks about is femoral, which we are not going to feel for that in class. It's in the crease of your legs, but that's the next pulse. There's one that your book doesn't mention. It's called the popliteal pulse. It's actually behind your kneecap. And then the last one that's mentioned is pedal pulses, and there's actually two places. First of all, like if this were my ankle, kind of like right behind the bone of in the ankle, you should be able to feel one. And then if this was my big toe and my next toe, kind of like come down right it's where the crease of your toe is, and you put your fingers kind of like in that area, you would be able to feel pulse in between your toes as well. Now, these arteries and veins are carrying blood around our heart, and we call that circulation. And there's actually two forms of circulation. You have the central circulation, which is going to all the main and vital organs, like your heart, your brain, your kidneys, things that you need for life. And then everything else is all together. That's called the peripheral circulation. Now, I mentioned that an adult's pulse rate is 60 to 100. When an infant is first born, their pulse is actually 110 to 160, and then they get a little older, they kind of go to like 90 to 140. 1 to 7 year olds, 80 to 120. 7 and older, 72 to 90, and then you reach that 60 to 100 by the time you become an adult. So as teenagers, you guys are going to be sitting in that 72 to 100 kind of range, probably, if you were to count your heartbeats in 1 minute. If at any point in time we get an abnormal heartbeat, we have to listen to it with a stethoscope with that apical pulse that we talked about. And when we're taking pulse, we're essentially looking at three things. We're looking at the rate, which is how many times in 1 minute does the heart beat. We are looking at, is it regular or not? Does it skip a beat? Does it pause for a second? That kind of thing. And we're looking at the quality or the strength. Is it weak? Is it thready? Is it bounding? Those kinds of things. When we take a pulse, the actual way to do it is to count for a full minute. Now, if it's regular and everything seems normal, you will find a lot of people will take the pulse for 30 seconds and then multiply it by 2. When we are having to listen with the apical pulse with the stethoscope, you're going to listen at the apex of the heart. So think about how the heart is shaped. It kind of comes down into a point. The goal when we listen with a stethoscope is to put the stethoscope right over the point of the heart. And when we listen with the stethoscope, it's important to know the different parts of the stethoscope. So the parts that we put in our ear are called the earpieces, and they come down and they form what's called the brackets. It goes down to the tubing. And at the bottom, some stethoscopes have like 2 ends. There's a bigger end and a smaller end that we listen with. The bigger one is called the diaphragm. That's used to listen to bigger sounds, louder sounds, like the heart and adults' lung sounds and things like that. The smaller side is called the bell, and we use that to listen to softer sounds, like maybe a baby's heart rate or a heart murmur or things like that. They're a little softer, a little harder to hear, and things like that. And when you're listening to somebody's heart rate, it makes this sound called a lub-dub, lub-dub, lub-dub. Okay, that is one heartbeat. What's actually making those sounds, you have valves in your heart, and as they close, they're making that sound. And so you're wanting to listen to make sure that's what you hear. Because if you hear something other than that, it could mean that their valves are not functioning properly, and we need to maybe take a closer look. So that is it for the pulse. On Wednesday, we will, I have some little sounds for you to hear of abnormal pulses and stuff too. So we'll spend some time Wednesday doing that. So now we're going to move on to respirations, which is the process of breathing. When we breathe, we bring in oxygen from the atmosphere. Now the air that we breathe is actually only 21% oxygen, but we breathe in that oxygen. It goes down into our lungs where there's a gas exchange that occurs, and the waste product of our body called carbon dioxide is picked up, and then we breathe that out. Now that exchange of oxygen for carbon dioxide, as I said, is respiration. Now we have 2 kinds of respiration. You have the external, which is what I just described, where you bring it in from the outside and you have a direct exchange of those 2 gases from the outside world. But there's also internal respirations where your body carries oxygen around, kind of drops off that oxygen, picks up the carbon dioxide in all the different tissues of your body. That kind of respiration is called internal respiration. Now, for an adult, normal respiratory rate, or how many times in 1 minute they breathe, is 12 to 20. When babies are first born, it's 40 to 60. Toddlers, 20 to 40. Small children, 20 to 25. You guys as teenagers are probably somewhere between 15 and 20. So, as you can see, just like the pulse, as you get older, it decreases over time. Both of those do. Now, the interesting thing with respirations is you should not really tell somebody you're counting them, because it can change the way that people breathe. Think about it. If I tell you I'm going to watch you breathe, you can change it. Okay, and the reason that is because your diaphragm is under both voluntary and involuntary control. And so when we count someone's respirations, we usually just pretend we're still taking someone's pulse and watch their respiratory rate that way, because we don't want them to alter their breathing in any way and us have like an abnormal finding, that kind of thing. Now, there's some terms that we use for respirations. The first is abdominal. This is when somebody uses their abdominal muscles when they breathe, but their chest is still. So like their belly moves, but not necessarily their chest. Stoppage of breathing is called apnea, and you guys may have heard of the term sleep apnea before. You may have a family member that has to sleep with a machine because they stop breathing when they sleep. Apnea can also happen during the day, but any stoppage of breathing is referred to as apnea. We talked about bradycardia being a slow heart rate. Well, bradypnea is slow breathing. And then we come to this weird kind of word called Cheyne-Stokes respirations. It's this weird breathing pattern of irregular breaths that people sometimes get. When people are not moving the air in and out of their lungs very well, we'll say that they have decreased respirations. And last but not least for that slide, if people are having trouble breathing and it's painful or difficult for them to breathe, if they're having shortness of breath, the term that we use to describe that is dyspnea. A few more terms here. Hyperpnea is fast breathing. Think when somebody's hyper, okay, they're fast and moving all over. So hyperpnea is fast breathing. Q-small breathing are these deep gaspy type respirations. Labored breathing is when somebody has to use all the muscles of their chest, including their shoulders, their neck, and even their abdominal muscles just to get air in and out. And so usually it's a sign that somebody's having trouble breathing if their respiratory or their respirations are labored. And last but not least, there is another term called tachypnea that refers to rapid breathing. Just like we had tachycardia for fast heart rate, tachypnea is fast breathing. Now, we said that the temperature was controlled by the hypothalamus in the brain yesterday. Well, today we're going to learn about a different part of the brain that controls your respiratory rate, and that's the medulla oblongata. No, this has nothing to do with like what the water boy said in that movie. All right, it is actually the as your spinal cord comes up and into your brain, like the very first part of your brain you get to is the medulla oblongata. And it is responsible for controlling how fast you breathe. It also actually controls how fast your heart rate is and stuff as well, controls your blood pressure. So if this area of the brain gets injured, it could be permanent, and the person may then need to be on a ventilator for the rest of their life. Some of the things that could affect somebody's respiratory rate could include diabetes, kidney problems, lung disease, stroke, anxiety, fear. All of those things can lead to problems breathing. There's 3 signs that somebody is having trouble breathing, and that's confusion, restlessness, and anxiety. When we see those 3 things together, it's a sign that they're not getting enough oxygen. So that's obviously a problem. And so we are going to kind of start looking at them for having respiratory problems. When we listen to somebody's breath sounds, when you guys go to the doctor probably listens to your lungs, okay? What they're listening for is to see if they make any sounds when you breathe. And so Wednesday, when I come back, I'll actually let you listen to some of those. But some of the ones that are mentioned there on your slides are crackles, stridor, and wheeze. So we'll talk about those on Wednesday. All right, guys, that's all I have for today. We talked about pulse and respiration. Yesterday we talked about temperature. So tomorrow we'll be talking about blood pressure. Or I guess not tomorrow. I guess it'll be more like Thursday, because tomorrow we'll catch up. We'll talk about a little bit about everything we've gone over. Make sure you're working on stuff. Make sure you're good for Mrs. Kimmel so we can do some fun stuff with this, guys, okay? I will see you tomorrow. Bye.